Welcome to the Meltzone Podcast. This is episode 66. I'm Tom.
And I'm Stefan. And we haven't recorded in a while. So on this episode, there is a bit of catching up to do in terms of like what happened with us, what happened on YouTube, and a couple of projects we recently had been working on. Like Tom did a super great video on, or a super great intro using an AI NERF technology for flying through support structures. So a bit of AI NERF discussion, and then a bit of rotary machining on the Snapmaker, and also a discussion on if we could use the rotary axis on the Snapmaker for some rotational 3D printing or even 4-axis 3D printing. You gotta find out soon.
Yeah, of course, discussions about how that would actually work, but watch the episode. We also talk about other slices that are more 2.5D oriented. The new PrusaSlicer 2.6, Prusa CAD possibly being an option there. Simplify3D V5 is finally out. And Lychee slicer now is an option for FDM printers. So more options, but also perhaps fewer than before because some of those aren't really viable anymore. And as a final topic, physical meetups. The Rocky Mountain Rep Festival is happening. We discuss what the plans are, and maybe there's even going to be a Bay Area Maker Faire in a completely new style from when it happened last time.
Yeah, so it has been a while.
It has.
I can't really remember when we released the last episode, but I think it was in October or November.
No, I think the last recording, because I checked the recording settings and we had to figure some stuff out just to get this working again, was November 22nd, I think we recorded. Okay. So, yeah.
Just after Form Next or before Form Next?
Man. Where have we been? I mean,
drowning in work and self-questioning.
Yeah, both of us. So surprisingly at the same time. For me, it was just the decompression after having to move out of the studio and just not being stressed out of your mind anymore. And all of a sudden, you like think about like what am I doing? Like, is this working out for me? Why does my shoulder hurt? That's the other thing. I've got a busted shoulder, and like every year it's coming back, and it's in pain to a point where I'm not able to use a mouse for a couple weeks a year. So that's not optimal for producing content.
Nah. It kind of sounds like the phenomenon that you're always getting sick once you take a vacation.
Yeah.
Because you were stressed out all of the time and just work your ass off, and then vacation starts and everything just falls apart.
Yeah, your body claims what it needs, even if you don't want it to.
Yeah.
So that's been me. You've been pretty stressed out as well.
Yeah, just having like 2 jobs and a family turns out to be quite a ton of work.
Yeah.
And I don't know, at some point it just takes a toll on you.
It's like, oh yeah, but you're a YouTuber, you've got the best life, you can do whatever you want. Well, you've got some obligations too. But let's not dwell on that, because people don't like it when we complain. We're not supposed to complain, we're just supposed to suck it up. So
but just maybe quickly staying on that topic. So for me, getting to like my Christmas vacation that was for I think 3 weeks, where I also wasn't at like normal work, I really didn't do any like long form video YouTube stuff, and that felt kind of good because I was finally able to finish a couple of things and also start a couple of things that I always wanted to, which is I did I think 2 or 3 short videos over Christmas. And even though that's not really the format that I want to do in the future, it was something different for me because if I had an idea, I was able to put that into a short form video in like a matter of hours or just a day. Which kind of feels cool, because I always struggle with like long projects and things like that. I want to finish stuff and then just move on, and just in the morning have an idea, record something, and finish the video at night is something that I otherwise don't have.
That's what my early videos used to be as well. Like the 6-7 minute explainer videos, how to calibrate the extruder, those sort of early videos where it was just reproducing stuff I already knew, where I didn't have to do any research or experiments for it. That was fun. Like, I start Saturday morning typically, write a script in the morning, film in the afternoon, edit until 9 p.m. and then hit publish at 11, and just have a video done in a day. I think that's nice. That's quick. There might not be much of a market for those simpler videos anymore, but with shorts and TikTok and all that sort of stuff coming up, I guess that market is being created. Like, people are expecting you to have shorter stuff that's not as in depth.
So I think our core audience mostly hates shorts videos, and I tend to watch them way more than I did in the past, because they're now way better integrated in YouTube, and there's a bigger market, so they're also
watched maybe 3 in total.
Oh no, sometimes I really binge them, because then you watch one and the algorithm knows what you like, and then you have second one, third, and shit. No, again, like 10 minutes are gone. But I think so far the feedback from my core audience wasn't that positive, because they don't like the format.
Yeah, of course they don't like it, because they came to you for your long form, in-depth content. That's what they're subscribing to you for, right?
Yeah. And I honestly hate the just browser YouTube app at the moment, because shorts and long form videos are not separated in my subscription feed. If I currently look at my feed, it's 50% just shorts videos, and I don't want to watch them.
But nobody uses the subscription feed anyway, right?
I do.
You do. You're an exception. Like, if look at your stats. Like, subscription feed is like 5%. It's all recommendations, front page, that sort of stuff. Subscription feed. I don't know how much longer that thing's going to be around, especially now that YouTube has a new CEO. Susan, what's her full name? Stepped down as CEO. She's been in charge of steering that YouTube ship for the last 7 or 8 years.
Yeah,
and it's easy to point to all the things that you don't like about the platform and say, yeah, she was the one who ruined it. I also see the voices who are saying, like, yeah, but remember, she created one of the most long-lasting social media platforms that actually created a sustainable model for creators to stay on the platform.
Yeah,
and that's quite the achievement too. Like, I'll be the last one to admit that YouTube is flawless, but also, like, it's my job, and it managed to be my job for the last year. So, she did something right.
She definitely did something right, because if you take a look at all of the other platforms, they're hip for a couple of years and then nobody cares anymore. YouTube has been like on top of the game for a decade, and the reason for that is that they created this ecosystem, this creator ecosystem, where content creators are getting paid for what they're doing. And this is the reason why new and good content is being released there. Of course, TikTok is nice, and you can gain a ton of traction in like no time. But if you're not doing any like sponsored integrations and ads and things like that, TikTok's not gonna pay you anything, barely anything.
Yeah. So it's the sustainable model. It's the question is, like, what is it for you? Is it a job, or is it just a hobby? Is it something you do for fun? And TikTok probably is great for that, but I don't see the model how you're going to make a living off of that.
You definitely can, but not because TikTok is paying you. TikTok, they are providing a platform that you can use to basically run ads for others and earn an income that way.
So it's all sponsorship based.
It's mainly sponsorship based. The amount of money that you can earn there is practically nothing, to be honest. Because
I was wondering, like, how can you do an ad read in a 60-second or 30-second video? Is it just going to be all? This is a completely sponsored video in your feed now?
It's different. It's different, to be honest.
To be fully honest, here is I've not used TikTok at all.
I do have a TikTok channel, and I think 3 videos on there. TikTok is not anymore only 60 seconds, so you can do longer format, yet portrait mode videos there. I don't use TikTok at all, to be honest, because I don't like the content at all there. I do watch YouTube Shorts, and the ad integrations are just way shorter, or just like a whole video about something in the end. And I don't know how much they're going to pay for that, because if I look... So I had basically 2 shorts videos explode in January. I got 10 million views on one video, but the audience is so different.
Of course.
So different to my core audience, that and also not in the group that have a ton of money. So they are like 14 to 18 mainly.
For advertisers, or not worth advertising to for advertisers.
Yeah. Ad rate's going to be different, but on the other hand, if you're doing beauty products, or I don't know, things that are...
I don't know. There's been
people can live from that.
Some controversy about how exactly ad funds are distributed to creators on YouTube, because it's like the first ad you see when entering the Shorts feed goes to YouTube exclusively. It doesn't get split up. Then there's like the entire a part of that earning goes to music licenses, and then the rest is split 50-50 between YouTube and you. So in the end, it's like what is it, 60-40, 60% for the creator, 40 for YouTube?
And I think the other way around. On regular videos?
On regular videos. 60% to creators, 40% to YouTube. I think Shorts is 50-50. No, it's music. I don't know. But it's a ridiculously small percentage of the actual ad revenue that goes to creators.
It is, but on the other hand, of course they are providing a platform, and just all of the infrastructure behind that also costs like a ton of money. So, and in the end, it's way more than Meta or TikTok or any other company is paying.
Meta are charging you $8 a month to even have an account now. Well, to even have a proper account now. God, that entire Plus or whatever it's called, Blue on Twitter or Facebook Plus. Anyway, let's do some. I want to do some 3D printing topics.
Yeah, let's do some 3D printing. Let's maybe start with. Shall we start with this one?
God, this episode's all over the place. Sorry, we're trying to get back into a groove, into a regular all over the place groove.
Maybe just a short one, because I really enjoyed that on your last video, and we talked about that in the past, and that was NERFs, which is neural. Tell me what it means.
Neural radiance fields.
Exactly. In the beginning, I thought this was just a different way to 3D scan something, but I finally understood that it's not creating like a 3D model of a scene, but it's calculating frames in bit or at locations where you didn't take a video or didn't take a shot.
Well, yeah, that could still be 3D scanning. I tried to explain it, and I'm not sure I've fully grasped it yet, but basically the NERF, the model you get. I'm using NVIDIA's Instant NERF, which is like the most accessible one if you want to try it out. Instant NGP. It's like a 10-minute setup, and that's it. It takes a ton of compute power, so Threadripper and 3090 on my side were completely bonked for 3 hours. So Yeah, it's super easy to set up, but the model basically takes the same input data as a 3D scan, so a couple of frames around your part, but it doesn't.
Is it frames, or do you need a whole video?
The NVIDIA process, it extracts frames from a video, or you can give it frames directly.
Okay.
So it's instant. It's single frames. Yeah.
Okay.
And then it doesn't care much about the 3D geometry. In the end, it can extract 3D geometry from the model it's building, but basically it's trying to, I don't want to say understand, because it's not a model that thinks, but it's trying to make sense of how different perspectives of different areas look. And that is not about the actual geometry, though it does reconstruct some geometry. It's more about, for example, reflections. If there's a plane in front of you, and if you look at it from this angle, there's a blue thing reflecting out of it, and if you look at it from another angle, there's a red thing reflecting out of it. It learns that this point right here, if you look at it from the top, has a different color or a different albedo, whatever, from that perspective. And so for basically different areas of the 3D scene, it tries to match basically its understanding of what each area looks like from different angles to the input frames you're giving it. So by extension, it can blend between those perspectives and say, okay, from this one angle it looks blue, from this angle it looks red, so in between it's probably going to be purple. Yeah. And it does that from input frames. So yes, you're right, it can reproduce perspectives that are not in the input data set, but just the same way as with 3D scanning, if you give it a perspective that you didn't capture in the input data set, for example, from the back, that intro scene that I did for PrusaSlicer 2.6 was only done from the front, only from the angles that I knew I needed. From the back, it looked completely useless, or from just slightly above, the entire model would turn like a uniform blue instead of having those specular reflections. So it's cool because you only need to give it those perspectives that you're later going to use. So for that scene, I knew I was going to have a fly through from the bottom somehow, so I only gave it frames from the front, and then you reconstruct it, or you let the program reconstruct it. You can create a camera path, and of course from there you just get your rendered images, and you can do with those whatever you want.
So what you basically did is, if you listeners haven't watched the video, go watch at least the intro of Tom's PrusaSlicer 2.6 video.
The next one's going to have a NERF intro as well. Not as good, but it's just fun to make those.
Yeah, and that's a cool thing, and we talked about that before you started recording. Sometimes taking the time to do and learn things that you enjoy is really relaxing and motivating. Yeah. So anyways, what you basically did is you did a fly through the organic support structure of the 3D print, which would hardly be possible to do with like a real camera, because you would need like an objective that was able to go in there.
Yeah.
And it was just impressive to see, and I think it was so well done. And if there would not have been like the rendered 2.6 and reflection, and I think
text
something like
there,
that,
yeah,
people wouldn't have noticed. If somebody would do a bit of, I don't know, video filming and photography and things like that themselves, they would have asked themselves, how did you do that? And when I first saw your video, I thought you bought one of these,
the probe lenses,
fancy probe lenses, and did that. But no, that's not necessary anymore. And this is so impressive. And I think you also said that on a previous episode, you could basically, if you're doing a review of a printer, scan it from all of the sides, and then afterwards you can do basically a fly through of the whole printer. You can
have a fly through, like that's what I'm thinking about. Like have a printer and have a complete like robotic.
Yeah.
I was wanting to do that motion controlled robot thing. Now Brendan is doing it, and he's probably doing it way better than I ever could have. But yeah, that's basically that use case. Have motion controlled camera moves that you can do, and you don't need to actually get a camera there physically. Sure, the probe lens, I don't think it would have fit through those organic supports. But even if
it would not. That was the thing. I thought, wow, how did you do that?
And even if it would have, with the NERFs, you can render depth of field. You can get a nice blurry background. With the probe lens, I think is an F16. So it's going to be super dark, and it's going to be everything's going to be in focus almost. Yeah. You can just set your aperture size in the NERF in the NERF render, and it's make it as blurry as you want. I will say though, the quality of output that I'm getting is not super detailed. I think from the 3D representation isn't super highly detailed. For me, I think it would work for up to a 720p render, and it would look basically as good as a real video. But what I had to do is I had to send it through Topaz Video AI, and that worked really well because the 3D print kind of had nice sharp corners and smooth surfaces, and it did a good job reconstructing that from the originally blurry render. Now the next one I'm doing from as a fly through of the Snapmaker. That didn't turn out so well. It's a bit more blurry, and I really couldn't get it to reconstruct that well in Video AI. That is sort of the downside. You're not going to get a super crisp output. There might be ways to tweak it, but I couldn't make it work.
But in the end, who cares? Because if you don't have YouTube Premium anymore, it anyway just defaults you to 720p.
Really? Nah.
I think there was a rumor about that, but I don't know. I do have a subscription.
Most people watch on mobile,
and
so
the other half just watches it on their phone, and those scenes are anyway so short that that if you have not done it yourself, you don't have enough time to figure out does that look right or doesn't that look right. It just needs to look good enough to just to make an impressive shot. So I'm excited to see what you're coming up with in the next one.
Yeah, so next one's going to be the 4-axis Snapmaker-y stuff. Posted a bunch of teasers about that. And that's been, you've already hinted at that, the NERF, that's been something that I've been just enjoying. There's no, well, I guess the PrusaSlicer 2.6 video is doing pretty well, so it might have something to do with that people are seeing the intro shot and they're going wow, this dude really knows what he's doing. But really, it's just been something that I've wanted to try out, that I've seen, that I've had some interest in. I've been playing with Stable Diffusion, of course. I've been playing with ChatGPT once that came out. Just new tools that are available. Just I think the same as everyone does. Trying it out, trying to make use of it, and seeing where the limits are, and trying to understand what is this thing that is happening right now. And yeah, so all the I think I've said this before, but I don't think we should be calling these things AI tools, because that would infer that there's intelligence there, which there is not. It's really just a different way of computing that's, with Stable Diffusion and ChatGPT, really just an autocomplete on steroids. Anyway, it's fun to play with. It's a new way of looking at things, and it's been fun to add that to my workflow and just try it out, because I've been making videos for almost a decade, more than a decade now. I don't know. It's been a while, and it's you sort of know the process by now, right? You know what you're doing more or less, and it's so much just mechanical work that it does take the fun out of it, and these sort of things. You spend a day or two, and it's just something you're engaged with. I guess let's jump into the rotary axis stuff, because that's also something
that you enjoyed.
Yeah.
Hopefully. 4-axis machining.
4-axis machining, 4-axis cam, or cam in general in Fusion is just, it's fun. it's something to learn about, and seeing the machine work is so. Just to set the stage here, I've had my Snapmaker A250T for a while. I've unboxed that mid last year, I think, and the rotary axis has been in the box unused for the longest time. And I finally unboxed it, did some stuff, let me hold it up to the camera. So what you're seeing now for the audio listeners is a tamper handle for espresso baskets. Basically, it's missing the actual tamper platform here, but it's hollowed out. You can see straight through it. It's sort of skeletonized, and that's been something that I've went to step by step. There were some mishaps where I couldn't really free it from its shell, and it's split in half in the lathe. But just trying those things and experiencing the machine working from the G-code that you created. It's that same mesmerizing thing that he had when he first started out 3D printing, and you were just staring into the machine for hours. And I'm kind of getting that back, and that's fun. That's just, that playfulness is sort of coming back.
So first question, why did you use Fusion for cam and did not use Snapmaker's Luban, or how's it called?
I don't have a beep button here, but the insult that I would spew towards the 4-axis tool or the 4-axis processing at Luban would not be safe for any podcasting platform or YouTube. Luban is not usable. Like, don't get me wrong, it's cool that they're including something, but if you want to do more than engrave pictures on a cylinder, like, it's completely useless. Okay. Something like this. No way. So this is with just a bit of sanding, but like the inside surfaces here on the cutouts, completely untouched.
Yeah.
You would never get this cleanly out of Luban. So it doesn't have any strategies, any adaptive clearing. It doesn't have rest machining, finishing, roughing, nothing. It's just one pass that follows the contour, and that's it.
Yeah.
And that just, like, no way. Like, if you look at the stock material here, this is what I've started with, and I'm turning this out of. I'm not going to do a 10 millimeter depth of cut in hardwood on that machine.
That machine, yeah.
Not happening. So yeah, Snapmaker's tool, useless. Like, don't bother using it. Go to Fusion.
I had the same experience when go to Fusion. I had the same experience when I tried or when I reviewed my Snapmaker, also I think beginning of last year, don't remember it anymore. I don't know, for basic things, and if you're a beginner, it might be okay to make some nice looking things if you have a ton of time. Something like that is just not possible. And I was happy that Snapmaker provided is it called libraries in Fusion, or the post processors?
Yeah, the setup. It's basically a Fanuc post processor basically that they're using, but they've got it on their website. You can just download, plug it into Fusion, and it's gonna work for the most part. Yeah. You're still gonna have to do your work setups and stuff, but you have to do that on any CNC machine.
Yeah, but the thing is, with standard Fusion, with the free Fusion 360. Horrible to say. You don't get any 4-axis machining. You only get 3-axis machining.
Okay, this is interesting, and I don't touch on that in the video, I think. But I'm an influencer. I've got the Fusion 360 influencer full license thing, and I think I've used some of the 4-axis, or I've used the multi-axis toolpaths, but you don't really need them. You can get pretty much the same results with the 3D toolpaths, and you can use those with basically the 4th axis at a set position. You can add a tool orientation, and you can tell it, do this toolpath at 30 degrees tilt.
Okay. And
then you can do a rotary pattern, in this case, every 60 degrees? No. Yes, every 60 degrees with 6 cutouts. You can repeat that same toolpath, or you can do basically a linear toolpath going over this over that way. So those are not really 4-axis toolpaths or 5-axis multi-axis simultaneous machining toolpaths. I don't think there's any yeah, even the ones that I used earliest, when it's like, oh yeah, I've got multi-axis, I'm going to have to use the multi-axis toolpaths. There were only 3 axes moving at the same time. So it was either the rotary axis, and then the x-axis was locked in place, and it was just following this way. It was never 4 axes simultaneous.
Yeah.
Those you really only need for super specific use cases.
Yeah. Cool. I also have the 4th axis, but I did not get it out of the box yet. I think it has been sitting in my basement for over a year now, unfortunately. Yeah.
But you've got the bigger one, right? You've got the 350.
I got the 350. Yes.
Yeah.
That gives me a bit more space.
Yeah.
Also less rigidity. Is your 250? Is it the cantilever design or is it the full gantry?
It's just the moving bed, the bed slinger design.
Okay.
What do you mean cantilever? I think that's the 150.
Okay, yeah, the 150.
The problem though is this could be a long rant. The Snapmaker is just it does. I know that the results look impressive, but it's not a machine that is done well for this sort of cutting job, because you mount first of all, the A250, it has the rotary axis, it's the same rotary axis, but it's a shorter distance between the spindle and the tailstock. And your effective usable length is like 4.5 centimeters. So from the tool colliding with the chuck and the tailstock, it's 4.5 centimeters of usable range. So what I already did on mine is I slid the rotary tool back off of the platform they give you. I'm just using 2 of the mounting holes instead of 4, so that I can machine this much. And this is the whole extent of what it can get on there. Like the tailstock is right here. And then on this side, you can see that the chuck was clamping onto this, and I did a bit of clearance so I could cut in here without the tool colliding with the chuck. You barely get any space here. And then the way that some of the things are handled, like it's nice that you get a tool change assistant, but you're supposed to use a piece of paper on your already machined workpiece. On something like this, like you touched on with your tool, you set that as 0, it lifts up, you change the tool, you set it back down. On this, there's no even surface. There's no, there's no way to set 0. And they could have done it a lot better in a lot of ways. The bed is wobbly, the tailstock is wobbly. It's just, you have to make so many compromises, and you have to make so many, it all feels hacky. Right, there's no way to align the tool to your rotary axis. You really need to know what you're doing to get a good result, or I don't know. You might just get lucky.
Yeah. The Snapmaker is a jack of all trades, master of none. It supposedly can do everything, and if you are patient and if you don't have a ton of space, I think it can be a really fun machine. But if you are expecting if you're expecting it to perform as good as a good CNC router, a good CNC, a good laser engraver, and a good 3D printer, you're gonna be disappointed. And that's the thing, because some properties or some specs of these machines just contradict themselves, and this is then the problem in the end. Weight, rigidity.
You can optimize for it being a 3D printer, but by doing that, you're going to optimize against it being a good CNC. And I think what trips me up about the Snapmaker is not that it's, I mean, look, don't get me wrong. It's an okay 3D printer, and I say that in the video too. It's an okay 3D printer. It's an okay laser cutter. It's an okay CNC. It's not good at any of those, but it's, if you, in a pinch, you can use them for those applications. But it's just, with a bit more care and a bit more attention to detail, they could have made it a good CNC, one that's more usable by, for example, allowing you to somehow align your tool, to home your tool into a work coordinate system. especially on the rotary axis, where that one flat surface they could have used to align it to the spindle, like the top surface of that rotary axis, that could have been a known distance from the actual axis. Instead, they put like a little groove in there, so there's no flat surface on there at all to align the tool to. It's like they have good tools, they have a good understanding of like how to design stuff. They just don't know what they're designing. And that's something that's bothering me about quite a few import tools, quite a few Chinese tools, where it's like they did the 80%, where it's like they did their homework, but they didn't actually use it and refine it.
But this is, I think, something Naomi said a while back, that from her experience, engineers and people in like the Chinese making industry, many of them, they're not like passionate makers.
Yeah.
Who design something, try it out, and then improve on it. And this leads to problems like you're having, that you always have either a total disconnect between the people that test it and the ones who design it, or that you don't basically do a ton of testing at all in the end, that you design things that look good on paper, but if you really try them out, there are many flaws with it.
Yeah. And this probably isn't just a design in China kind of thing. It's, look, at my office job in the automotive industry, I got that same feeling, where it's like you do your job, you do whatever the customer wants, or the customer as in the company the company that's going to be buying the parts from you in the end. You do whatever they want in their spec sheet, but it's not your job to question whether what you're designing actually makes sense. No. You just do your job. You design so that your superiors are happy, that your project managers are happy, and once they give you the green checkbox, you move on. I don't think people, especially now that like everything is so hyper competitive, I don't think people really care anymore about the stuff they're doing, especially once it's on a scale where there's, like I said, where there's competition.
And I think also that a ton of things are outsourced, that you don't have a ton of feedback in the end. And this is something that I really enjoy in my job, especially when we were starting with metal additive manufacturing. I was doing design, I was doing part preparation, but I was also like standing at the machine, printing parts, depowdering parts, looking what failed and what worked, which helped us a ton in getting the process going and designing better parts in the end, that the engineers were also like manufacturing stuff and finding out what works and works not. I'm totally aware that something like that is hardly always possible.
Yeah, I was going to say that's probably a luxury to have, that
definitely
your process is so compact that you can do that you can have one person who understands the entire thing from design to application.
You need the right engineers for that, in terms of their skill set, but also in their interest. I know other engineers who are wearing shorts, a shirt, and who would not really like to stand in front of the machine getting powder all over them, or I don't know, breaking parts of a build platform. They want to design parts, but they don't really want to know how they're manufactured and things like that. Yeah. But this is something that I enjoyed and I think helped us a ton. But when you're growing bigger and bigger, at some point it's just not possible anymore. But this is the thing that I really enjoy, like in my professional job and also in my YouTube job, that I basically have control over everything, even though if that's from like a business perspective something really horrible that I do everything, but it helps me to tune everything in, and I enjoy understanding the whole process chain.
Yeah.
And this way gain knowledge and also to make the process more efficient and to learn and things like that. So
Yeah, and like I said, that's a luxury to have. There are certainly benefits to it, but at some point, at some scale, it's just not possible to have that anymore. Right?
Yeah.
Going back to my automotive job, I think the suppliers making like metal powder inductors, they don't know how they're going to be used in the end in a power supply for some amplifier that's going to be having this sort of low profile. They're not going to be able to optimize for that use case in the end. It's just not possible. And in the end,
possible. And that's the reason why you have a specification.
Exactly. In the end, you have your spec sheet. You get your Lastenheft. What's it called in English? Your list of requirements, basically.
Yeah.
That if you hit those marks, then your job is done. And
But that requires that both the Lastenheft, the list of requirements, and the specification includes everything. And if there's something that's not accounted for, then this doesn't work anymore.
That is very true. Yeah, and I could tell some stories here, but
So for example, I think I read this today somewhere on the news. BMW or Audi or VW, some of them said that they gonna develop their new electric drive trains totally in-house because they see efficiency benefits up to like 20% doing everything in-house, and maybe not have the problem that you need to write a specification, need to be sure that everything is in there, and over-specify stuff or not specify things at all, because you can iterate way quicker, even though that requires that you do anything.
It's
everything
like
in-house.
it's overhead both on the side of you trying to spec it and on the side of the company who's actually developing it.
Yeah.
So in my case, I'm not going to name the customer here, but we were getting specifications from the customer for, I'm just going to say 1,000 watts of output power. So they probably intentionally overspec that. 1,000 watts on an audio system is crazy. Like if you have any sort of efficient drivers, you're going to blow people's eardrums out. But they specified 1,000 watts, so we were like, okay, 1,000 watts, yeah, we can do that for 2 seconds. Because it wasn't specified for how long that output power would need to be maintained. So we engineered for 2 seconds. Because, I mean, realistically, if you have an audio driver with an efficiency of, I don't know, 80%, that's really good. That's 200 watts of losses. Like, look at your CPU cooler for 200 watts. There's no way you can do that in an automotive temperature range in a package that's as big as a 4080. So yeah, those loopholes, people are going to find them, and people are going to make use of them. And then on the other end, you have to account for them. And when you're specifying stuff, there's so much communications overhead. But that's probably a different topic.
That's definitely a different topic. Maybe staying on the topic of Snapmaker and rotary machining. The thing I wanted to do with my rotary axis is rotary 3D printing. Did you think about that?
Yes, I did, but does the machine allow it? Because the Snapmaker goes into, it's CAN bus, right? The entire machine is CAN bus. As far as I understand it, every axis is a CAN connector. So the drivers are in the axes, and the plugs you plug into, there we go. I think the bed is the one that's like completely analog, which is the one I have here. But the drivers and the linear axis, the rotary axis, the tool bus are all CAN bus. So if it detects that the rotary axis is installed with a CNC tool, and it's like, hey, I'm a CNC now. I'm in CNC mode. And it's only going to read your .cnc files and not .g code. Does it actually allow you to use the rotary axis in 3D printing mode?
So when I received my 4th axis, Snapmaker had either on their product page or somewhere a video where they did rotary 3D printing.
Huh. Then it should work.
It should maybe work. I don't know if that was just like a demonstration and it looked nice, but I think I remember I have seen, and I wanted to try it out and thought about ways on how to do it and what the problems are that you're gonna run into. Because one of the things is that depending on your distance to your rotation center, the extrusion amount needs to be adjusted, because I don't know, the length of a full rotation 10 millimeters away from the rotation axis is way shorter than 100 millimeters away. And if you're using like a normal linear slicer, you would need to, I don't know, do some kind of G-code post-processing to, depending on your Z position, adjust the flow or something like that.
Yeah. And then, of course, if you want to reproduce something that is like dimensionally accurate, you would have to pre-warp your STL to basically, if you slice for 2D, it would need to taper and get thinner towards the top. Which, I mean, not impossible to do, right? With a bit of Python, you could probably post-process that.
Yeah.
But like the question I have really is, does the machine allow you to do it? Because the Snapmaker has its main board, it has the USB-C plug in the side, but I don't know if you can actually plug in just a regular, Prontoface host into that.
Probably not.
So it has its control module, like a 6-inch Android 7 tablet phone, and that controls the entire machine. And it's really, you don't really get any direct control over the machine. I don't know if you could control it through USB. I think you should be able to make it work. But with the module, if it doesn't think it should allow you to do it, you're not going to be able to do it.
The question is, so would you be doing 4-axis printing, or would you just do 3-axis printing and use, for example, instead of a Y-axis, the rotary axis? Because I think that's low-hanging fruit, and that's what I would have started with, because then you can just trick a normal slicer into generating G-code for that.
Yeah, that probably make that work first. That would be my thinking too. Basically, yeah, you're still just doing 3-axis printing. The same like I said with Fusion, where you do basically a 3-axis toolpath, but instead of using like the Y-axis, you use the rotary axis.
Yeah.
Doing a full 4-axis, we get into the same challenges that we see with every non-planar slicing approach, where how do you determine which angle which part should be printed at? Because that's really what it comes down to. The 5-axis demo that we saw at NERF does have the workflow with what's
full
it called?
Control.
Not with full control, but with Rhino
and Grasshopper. Yeah.
But that hardly is a slicer. That's more of like a generative G-code approach.
Yeah.
And this is another thing that I thought about. Like, how would you implement non-planar slicing? This is just shower thoughts at this point. And I don't think it should be this hard to implement, but you could do non-planar. I know we're skipping topics here. We've got so much stuff to talk about that's just built up over these months. I'm sorry. Non-planar slicing, right? The question is always like, how do you determine which angle, which parts of the model should be printed at? My camera's already flickering again. Wow. So my thought was, let's stick with a traditional Cartesian XYZ 3D printer first. My thought was, we look at the model, we look at the angles that our facets are at, and we create basically a flow field. We create a separate 3D voxel field around the part, and we determine, okay, this would be the optimal angle. So each voxel gets a vector of like the optimal printing angle. Then we fill the inside of the part, basically as an extension of the surface, fill the inside of the part with that same flow field. And then you go up from the bottom and you limit the angles that subsequent layer can be at. So let's say you always start at a flat angle, and then as you move up, you can sort of transition into, let's say, up to a 30-degree angle that you could do with a pointy tool head. You transition to that, and it doesn't have to be planar. because it's a field. It can, your layers can flow through that. You look like I'm losing you.
No, it's totally fine.
So basically have that approach and have the layers morph as you go up the part. And keep modifying that flow field until you get something that is within the limits of what the machine can handle.
Yeah.
And I guess by extension you could extend those limits to include more rotary axes, more access to the model.
Yeah.
That would be something that I think could be a universal solution to multi-axis slicing.
Yeah.
And what we've seen so far has always been either a handcrafted, what we've had at Formnext, I think, where it's literally a robot that can do like pipes that snake through the air, but that's literally handcrafted G-code. Or you say, okay, this part is going to be printed with this orientation, and then you slice off a part and you reorient and you print onto the model.
Yeah.
And it's not one continuous print. So I don't know. I've thought about like how could I program this myself, but it's probably a bit too much for me.
It's probably a bit too much, and I think the problem is once you start, you notice how many edge cases there are and how simple just normal 2.5D slicing is.
Yeah,
and you just want to leave and cry.
Yeah, like the thing that obviously comes up is collisions. Like, what if you have, I've got this power supply sitting here. What if you have two prongs or two fingers that are next to each other and they twist like a DNA helix? They twist in different ways. Like this area would be printed like that, and then the other one would be printed the exact opposite way, and you'd crash into the thing that's already printed. It's not easy.
It's definitely not easy, and I have already talked about that in the past. Who has currently the incentive to do this kind of development? If you are a printer manufacturer, so the only one who could have an incentive for that, who creates a machine that is specifically designed for a non-planar printing approach with the nozzles, the cooling system, and everything that needs to work or needs to be specific for that approach. And then you have your slicer that uses your freedoms of your extrusion system. But I don't know, PrusaSlicer, they won't be implementing something like that, because if you look at a Prusa Mark III print head, it's basically like 2 millimeters over the print surface. You can't do any non-planar printing there. And I also talked to a guy who did a lot of non-planar slicing in the past, but he also said his problem is funding. If he does the same job for an established company, he gets paid a shit ton of money to implement that in their software. So the only possibility he would see it for him personally is if he would be able to fund his work in a way. But if you take a look at what good software engineers earn in a month, you need a ton of Patreon money for that, which is kind of unfortunate. We get to that in a second. I was hoping that, I don't know, Simplify or some other slicer would implement at least a teeny tiny bit of non-planar slicing in their slicer, because I think this would have been a feature that would have set them apart from all of the other free ones, but wasn't there. And I think it's also the problem that you need to pay attention, that you make sure that every edge case is looked out for. You need so many parameters, like how is your print head formed, how wide is the nozzle tip, what's your nozzle diameter, what's the nozzle angle, blah 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 blah. So it's just complicated, and
it's also a chicken and egg problem to an extent. Like I said, with like a Mark III or so many other toolheads, you're trying to get the fan shroud as close to the nozzle as possible. So you can't actually do it without modifying your machine. So what incentive is there for a slicer producer programmer to implement that functionality when nobody can use it? like I said, it wouldn't need to be a company who makes a printer specific for that, who also makes a slicer for it. But that's a very limited set of
Maybe just a quick one right here. So when I thought about that, I know that some modern CAD tools, like Siemens NX, for example, does that. I think Fusion 360 also started doing that in their beta or pre-release features. Directed energy deposition slicing. So if you have a MIG welder on a robot arm, slicing for that 3D printing approach. Multi-axis.
That approach, DED approach, or that approach?
No, the DED approach. Okay. And instead of just feeding metal wire to the welding head, just either they have implemented to use G1E something, or to do a bit of post-processing and just use the already existing tools that are made for multi-axis 3D printing with welding heads, and see how that works on a Snapmaker, even though the software probably costs you like $100,000 or $50,000 or something like that, just to see if that would be applicable on such a system.
Yeah. My first thought when he asked, like, hey, how are you actually going to do the slicing for it, was like, couldn't you just use an adaptive toolpath in reverse? Just basically use a milling toolpath and have it extrude material instead of milling it away, which I think with the right parameters you could kind of make it work.
You could make it work because they have the constant chip width.
Yeah, constant optimal load.
Optimal load.
So the tool is always going to be in engagement by a millimeter, for example.
Yeah.
But it can also say if the tool head is in less engagement than a certain amount, less than a millimeter, skip that toolpath. So it's not going to be super clean, but it might be something that he can do. And you've got rest machining, so theoretically you can do like the cut a part off and do that. Might be an option. Yeah, that's a really interesting approach.
Just
demill your part. Wasn't there this weird 3D fax kind of thing where you'd put a 3D model into the machine and it would mill away one layer at a time, and it'd scan it, take a photo and send it to a different machine that would print that, and then mill away another layer? And I think we even talked about this on the podcast.
Okay, I don't remember it anymore.
It might have been more art project than actual product, but kind of the same thing.
New project, demilling.
Yeah.
Not the worst idea. Never thought about that, but that would. And the thing is, Autodesk has one of the patents for exactly doing that, for 2.5D printing at first and then do a 3-dimensional path over it. So use Fusion, so maybe you get around the patent. I don't know.
I don't know, but yeah, we were talking about slices, and I guess this is one of the actual topics that we've got today. There's 3 slicing topics in here. So we've got PrusaSlicer 2.6, which is now in Alpha 4, and it's pretty cool. It's pretty neat.
In my opinion, the organic supports are honestly a game changer.
They look really cool too. I mean, let's not forget about that.
Yeah, not only do they look cool, and that's definitely a thing, but when printing parts, prototypes for geometries that were not designed for additive manufacturing, this supporting approach saves you a ton of material at first and makes the supports removable so much easier.
Yeah.
So it's not only cool to take a look at them, but if you have designs be it artistic ones or just in a prototype shop, where you just want to have a part and hold it in hand and take a look at it. This is a game changer, because before you either had the possibility to use soluble supports, which are a pain to work with, in my opinion.
Yeah.
You could use standard supports, but then most of the time you aren't able to remove all of the supports. And if you're able to do that, you break half of the tiny stuff that's in between. Your part looks horrible in the end because sometimes it fuses too much, blah, 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 blah.
Yeah, that I think is not something that is like specifically solved with organic supports.
It is, but since they try to grow away from the main structure,
right.
There are way less contact points on the already existing model with organic supports than we had in the past. And for all of the models I tried it so far, it looked great. It saved a ton of time, and it was so much more efficient.
Yeah, and the fact that the individual trees, the individual branches are already kind of broken up for you makes removal a lot easier, because it's not one big block that you're trying to chip away. It's, if you've ever tried to remove a support block, it's kind of like almost like a styrofoam consistency that you're trying to dig through. So you can most of the time they just fall off by themselves. You give them a bit of a knock and they pop off. But yeah, material savings and all that, it's pretty good. But let's not forget about the other features of 2.6 as well. The
embossing.
Yes, that text wrapping.
Text wrapping.
I pointed that out in the video. Like it's such a pain to do in Fusion, and I had an example in there where I tried to do the exact same thing in Fusion, and Fusion just kept throwing errors because the geometry wasn't perfectly suited for projecting the text onto it. And this is one of the benefits of PrusaSlicer kind of not being a CAD tool. It doesn't have to work precisely. It can just slap it on there and say, yeah, this is good enough. We're just going to project it on there and like, yeah, that looks all right. Then you've got the splitting feature with pins. I think that actually is much bigger of a feature than people realize probably. It's just a pain to do in CAD, splitting it, adding pins, and then doing like the Boolean combine with its, and there you can just slice it in half, click, pins, done. Yeah. So the thing that people have been discussing, and I probably planted that seed, is like, is there going to be Prusa CAD? Are we going to see a 1-2-3D design sort of tool from Prusa? Because the PrusaSlicer is moving in that very direction, even though the geometry engine behind it probably isn't made for it, but the features are just coming together. And we've seen people on Twitter post about stuff they've designed exclusively in PrusaSlicer, like a little heart vase where they made out of primitives, cylinder, cube, made it a little hard, warped that around a surface by cutting away, used patterns, and then had like a heart pattern on a vase. Never touched a CAD tool. Used only the tools, only the primitives included in PrusaSlicer. And I think that's pretty cool. It's maybe not the job of a slicer, but it's pretty cool.
It is really cool. I think it makes it more approachable, and it's also nice to have it just in one tool and don't have to switch between ones. I never used Tinkercad, to be honest. I grew up with CAD software, parametric CAD software. Yeah. So for me, working on a mesh is always a pain, or is something that I just don't see in engineering. When I was young, I programmed games and used Milkshape and Autodesk 3D Studio Max and things like that. That's where I started. So I've been modeling so much stuff and clicking all of the triangles by hand, placing points, and so I know what a pain it is. But I see applications for it when you're doing artistic stuff. When I design things, I want this length to be 5 millimeters and this 6 millimeters, and I don't know, that's just how I was educated. But I know for a fact that for many it is kind of hard to start working with a parametric CAD software because it's so complex. So having possibilities like this in PrusaSlicer is, in my opinion, a game changer in professional additive manufacturing, for SLS printing, and or also for direct metal DMLS printing, for metal 3D printing with powder. Materialize Magics is a very established software there because it is also a great tool to work on mesh, to cut meshes, to do texts in there, to generate support structures, to align them, to orient them, and all of that stuff. But this tool costs like, I don't know, tens of thousands of dollars in comparison to what PrusaSlicer is doing now. And especially the embossing tool, there aren't that many other tools around that do such a great job. So, and that's the reason why I find it so interesting, and opens the opportunity to just have a simple to use tool, but also powerful tool that's accessible for everyone, which I really enjoy. So I really like to see the direction where Prusa's heading, and I kudos to them that they pour that amount of money in PrusaSlicer, because this is what brings the industry forward, and we see other tools adapting or adopting that. I don't know, Bamboo Lab or Bamboo Slicer has integrated many of the things in there, but on the other hand, then Prusa implemented the step import, and if you look at organic supports, that's coming from Cura, and Arachne Slicer is also coming from Cura, and then probably things from PrusaSlicer is getting back into Cura, and that mix-up and open source mind is great for at least the users in the end.
Yeah, how sustainable it is for the companies, I don't know, and this is a big topic that I'm very torn on.
Maybe not something to discuss in this one, but for the moment, I highly appreciate what they're doing. Slicing. One, I think two things are also really interesting. Three things. The measuring tool, I love that. I wanted to have that for years, because I use that in Materialize Magics in my professional work quite a bit, just quickly measuring out stuff. It's not working as well as I wanted, or as well as I'm used to use it in Magics, where it automatically recognizes, I don't know, circles and all of that stuff.
That's the exact same way that it works in NetFab, which is where I know the measurement tool from, and NetFab is kind of going away, maybe. I've not used it much because the licensing is all weird now. But yeah, NetFab has that same thing where it does circles, and you can do distances between hole to hole or surface to point, and PrusaSlicer is really just point to point or triangle to triangle. It's very, very primitive, but it's
the first release.
That too, and there's no other tool that can do that right now, as far as I'm aware of. Like, everything else is just an STL viewer or a slicer, but no geometry inspection tool in a way.
Yeah, I often did that measuring just in Fusion 360, because in Fusion 360 you can import the mesh and then use the inspection tool to also...
Up to a certain poly count.
Up to a certain poly count, yeah. So, great feature there. Also, I haven't used it myself. Speed adjustment depending on overhang angle. That's something I think comes from... I know that it is in Bamboo Slicer, and Bamboo uses that quite a bit, but I think that's stemming from SuperSlicer. And in Bamboo Studio, that really helps to print even the steepest overhangs, to print parts with very steep overhangs where you would have cooling problems if you would print them too fast, to get still really nice results. So, cool thing there.
Yeah. It's maybe quick interjection here. The who had it first? That's one of the points I had it here. So what the PrusaSlicer developers pointed out of like saying, hey, you copied this from Bamboo Slicer, Bamboo Studio, is no, it was in the code base that Bamboo Studio is based on PrusaSlicer. It was in there the entire time, just Bamboo Studio enabled that feature. Like it was in the code base of PrusaSlicer, but for the PrusaSlicer release, it was not enabled yet. For example, I think the hinting feature with like, hey, this might have overhangs that are too steep. So just pointing that out there. I don't know who's copying from who, but like some things may just be in the open source code that's out there and just not visible in the actual end product yet.
Many of these things can be accessed in SuperSlicer, and I sometimes really enjoy using SuperSlicer, but on the other hand, even though I like settings, SuperSlicer sometimes overwhelms me with settings. So one last feature that is already from PrusaSlicer 2.5, and there wasn't a lot of recognition for it, but this is, I think, in my opinion, a game changer for Bowden-based printers. Is if you have a speed change in a printing move, that you don't change the printing speed from one point to another, that you can enable a gradient, so it slowly transitions from one speed to the other. And I think where you could potentially see a huge difference is if you use different speeds for the internal and external perimeters. On direct printers,
the classic blobs on the surface where you go out to.
So on direct printers, you often just print with a way higher speed, the inner perimeters in comparison to the outer perimeters. I found it with Bowden printers, it works the best if you just have the same speed for all of the perimeters, because that speed change from very fast to slow will lead to a ton of over extrusion at the point where it gets to the outermost perimeter, which looks horrible on the surface. Yeah.
So you really want I a couple of years ago, I think, trying to explain that is like a Bowden system really is a constant pressure system, if you want it, because it has so much smoothing, so much elasticity in the path between the extruder and the toolhead that really you can't directly control it. Though with and this doesn't just apply to Bowden printers but also to direct printers, pressure advance is really, if you have a system that has pressure advance tuned in, for those of you who don't know, it's basically, okay, how do I explain this without more technical jargon? It's a system that tries to predict the delay and the lag and the transitions of your extruder from high pressure to low pressure, so high feed rate to low feed rate, and tries to apply the exact opposite of how it's lagging behind. So with a pressure advance, if you go from a low feed rate to a high feed rate, it's actually going to overshoot in how much filament it's pushing in, and then it's going to slowly taper to your actual feed rate. So if you've got that perfectly tuned in to your extruder, theoretically, you wouldn't need that sloping feature in PrusaSlicer. Theoretically.
Yes, definitely. So the sloping feature is especially usable either if you have a stock printer that can't do pressure advance, or pressure advance is not a perfect solution for Bowden printers because the system is so complex that you can't perfectly tune it in for all of the cases, and I think that helps just smoothing out some of the problems. These like fast transitions between printing speeds. I only tried it a little on my machines. I think in the 2.5 release it also just said, it's gonna be preview. We didn't test it a ton, but I found it really interesting.
Yeah, all in all, just little things, just all these little things coming together to make something that is just incrementally just getting better every time they release a new version.
Yes, talking about new version. One last thing. Such a good segue.
Sorry. One last thing that you should keep in mind with slicers backed by companies who also make printers is they're going to prioritize bugs and features based on what their machines need. Just that's how business works, right? That's you're going to prioritize your own stuff before you care. Apply your oxygen mask to yourself before you help others. You can't help others if you pass out before you get to them. And that's something that's been pointed out too, is there are issues and bugs in PrusaSlicer with multi-material or multi-tool head changing machines that are unfixed for like 2 years now, and that people with an E3D tool changer have been running into and have been complaining about for a while. And now that the Prusa XL release is starting to creep closer, the PrusaSlicer team is finally fixing those bugs. It wasn't an issue for the Mark III or the Mini, but now that they have the XL, sometime soon, Valve time, it's an issue and they're fixing it. So just keep that in mind. Like, this is not a product that is out there for the community. First and foremost, this is a product that is made to support the Prusa machines. And if there's a different use case that it's not optimal for, then they don't really have an incentive to make it optimal for that use case as well.
Yes, I read that Twitter rant, and I don't know. I'm behind you there. Of course, they try to fix as much as they can, but they're just prioritizing their stuff. And I don't think that people should be in the position complaining about features that are way out of what the...
I don't know that there is. I see both sides of the discussion. I see that there's a problem and that it's not being fixed, and especially when it's a feature that's implemented and it doesn't work correctly, then it's like, you're shipping sort of a broken product, and either like not have that feature or fix it. In between is kind of meh, and especially with the background of PrusaSlicer basically having taken over the Slick 3R development, taking that open source project and putting so much effort into it that the original development is gone. Like, everything has transitioned over to PrusaSlicer from the original Slick 3R. Especially a point where it used to be a community sort of open source project, and now it's a Prusa driven, still open source project. I think that's a bit of a trickier situation.
Yeah, you're right. But on the other hand, they could just remove the feature at all. If people complain that it doesn't work, would that make it any better? But
I don't know.
There are always two sides to the medal, but
Am geschenkten Gaul schaut man nicht ins Maul. Yeah,
that's the thing.
You don't the gifted horse kind of thing.
Yeah.
But here's the thing, when there's no real alternatives, when there's Cura, but that's optimized for the Ultimakers. It's the same thing kind of. When there's no alternative to that product for your use case, then I don't know. Though maybe Simplify3D V5 is an alternative.
Yes, talking about, the meme is over.
It's finally happened.
I think 2 or 3 weeks before they first released Simplify V5, I received an email and they said, that V5 is going to be a thing. And I barely believed it. I seriously barely believed it. There were so many rumors around, and I don't know.
And now it's out and nobody cares.
It's out. Nobody cares. And I'm honestly disappointed. And I also told them that.
Why? They did what they promised. They released V5.
They released V5, and they said, there are 170. Why is my... Sorry, my camera's always focus hunting.
It's a podcast. Like,
it's a podcast.
Look at this. Yeah. Camera's secondary.
160 new features and improvements and things like that. I opened it up. It looked a tiny bit different, but there basically weren't any like major new features. It is still a good slicer. it is probably the fastest of all slicers to what I have tested. It's faster in slicing than Cura, it's faster in slicing than PrusaSlicer. But the reason why people bought Simplify3D 5 years ago, that it had features that were outstanding and worth the price, are not there anymore.
Wait, you mean they removed them, or
no,
it's just that it doesn't have unique selling points anymore?
It doesn't really have unique selling points anymore,
okay.
Or this unique selling points I purchased it for 5-6 years ago. I purchased it why it was the slicer that made the best support structure.
Yeah, that's what it's known for, obviously. And then, of course, the processes,
yes.
the advanced controls you got with that.
Yeah. But all of the more advanced features that we have seen being implemented in other slicers in just the recent 1 or 2 years, talking about Arachne slicer, or Arachne perimeter generation, talking about the organic supports that I think are a game changer. Yeah, none of that is in there, and so that would have only put them on basically the level as other free slicers. But I think for spending $200 on a software, there needs it's $200 now. It's $200 now. It used to be 150.
139, I remember faintly.
I think I bought it for 149.
Yeah.
You get a discount. I think you can upgrade it for like $99 if you purchase Simplify in the last, I don't know, year or something like that. There's also a difference in the licensing strategy. So before you purchased one license and could use it on 2 machines in parallel. Mm-hmm. That's not possible anymore.
So two computers.
2 computers. Which, well, I have a laptop, I have the machine right here, so yeah, I had it installed on both machines. This is not possible anymore. You can only just activate it on one machine. There is somehow a floating license thing, which is kind of common for other tools. So you can install it on as many machines as you like, but can only use it on one machine at a time.
Which is fair enough, I'd say.
Which is fair enough, but I don't know if that costs more. There isn't any pricing listed on their website. I just know that from like regular software, a floating license usually costs like, I don't know, 2 to 3 times the amount of money than a node-locked license that is just activated on one machine.
Because typically floating licenses you would use in a conversion environment where you'd have, I don't know, 50 engineers who would all use the same tool, but they wouldn't all use it at the same time. So you'd get like 5 licenses for them, and then each one could grab a license and use it for a while and then give it back, and somebody else could use it. While I'm talking, quick correction about the upgrade abilities. So licenses that were purchased in the last 12 months are upgraded for free. And all other licenses, there is a one-time discounted payment required to upgrade to V5. This is a direct quote from the website.
Okay.
So last 12 months is free, and then older than that, you get a discount.
Okay. So they added a couple of new features. So they now have dynamic layer heights, but that's also something that we've seen on other machines. They have seam hiding options. We have had that in Cura for 10 years now, for 5 years or even longer, and it's something very common. They improved a bit the handling of, or the generation of their custom support structures, which is still a nice thing, and I think still working well. But comparing that to what we have with, I don't know, just organic supports now, it's different. One feature that I don't know if that's available in PrusaSlicer or in Cura, which I found really nice in the new Simplify3D version, is the dynamic infill density. So what they're basically doing, if you say you have, for example, 10% infill in your part, and then a dense layer starts, so we print something on top, they will, if you activate that feature, they will gradually, or I don't know, just in one step, add a couple of denser infill layers before like the fully filled layer starts. Right. That helps you with like grouping of the material and things like that.
Cura definitely has that. Cura has had that for a long time. I don't know if PrusaSlicer has it, but
PrusaSlicer definitely doesn't have it, but maybe SuperSlicer.
Yeah, Cura 100% has it, because I've used that exact feature 5 years ago or something, for setting up like huge scale 3D prints. Yep. But both of them have, well, I mean, PrusaSlicer has like support cubic and lightning infill and all those options where it's like you have super sparse infill, and then only where you need it, it actually generates denser infill. Yeah. So it kind of has something similar in feature. But both Cura and PrusaSlicer have the adaptive cubic infill, where towards the outside of the model, your cubic infill gets denser. Basically, it subdivides those infill cells and adds more material in the center. But typically, that is something that only works on like really large models. Yeah. Because it always tries to fit like a full cell of sparse material on the inside, and typically your models don't have enough space to actually reduce the infill density there.
Yeah. I complained about those things, and they basically told me that they want to be just a let me put it this way. They want to be a well-working, reliable solution where you don't need to be afraid that things change too fast. I don't know. That's not what they said.
They want to provide a stable platform.
They want to provide a stable platform, and I think this is also one of the reasons why Simplify3D is kind of popular by commercial printers that don't slap their interface on just Cura or PrusaSlicer. And to be fair, it still works good. It slices really nicely. It is a good slicer, but if you're looking for like the newest feature and especially outstanding feature, Simplify3D is just not cutting it anymore. If you,
it's probably just not worth the money anymore.
It's not worth the money anymore.
It's like I said, it's still okay. It's still a good slicer, but there's no reason to get it.
If you have only been using Simplify3D version 4.2.1 or whatever it was before the release, and you can upgrade at a discount and you want to have some quality of life improvements, I think it might be worth spending the money. But for anyone who's used to other slicers, just there's almost no reason to use it anymore. One thing I have to give them, and this is something that I kind of miss in PrusaSlicer and in Cura, is when I did parameter investigations in the past using processes in Simplify3D, was really nice. So I could have had parts with 10 different parameters totally easy on one print platform. This is, of course, now also possible with PrusaSlicer with the part-specific settings, but only to a certain degree. Yeah, to an extent.
To an extent, you can't do all settings, and I don't find it super usable, or it's not. It is usable. It's just not user friendly. It's like very click heavy and convoluted to get all the settings set up for individual parts.
If you're only worried about infill percentage and the typical infill percentage parameters, top bottom layers, it works really well. But what I used to do in the past is, for example, different nozzle sizes or different print speeds and things like that. This is just not possible stock in PrusaSlicer, and I always need to use G-codes for that, which is not so nice. Yeah, that's it.
But perhaps with Simplify3D not being worth it anymore, maybe Lychee Slicer is now the one to go for, because they now support FDM. Lychee Slicer, of course. Sorry for the forced transitions here, but we need to keep moving on here. I'm kind of running out of energy. So Lychee Slicer, I've not done a ton of digging into this, but Lychee Slicer has always been an alternative resin slicer, so SLA resin printer for basically, I think for the first Elegoo Mars machines. That's right about the time where it came out, and I think there's a free version, but it's also a paid software that you can spend money on. And it's done some stuff better than Shit the Box has done in the past for the machines that use that, and it now supports FDM. And it's interesting to see a slicer coming from that angle, because the tools you're using for resin printing, like hollowing or I think splitting and stuff, is something that is like super integral to Lychee Slicer. Now is just there for FDM as well. Yeah. You can kind of see that in PrusaSlicer as well, where it really switches the interface between FDM and SLA mode. If you select the TSL1S or the Mark III, it gives you a really quite different interface to use, because it's just different tools that you need for the different processes. And yeah, it looks like Lychee Slicer now is carrying those features that they specifically used for or specifically developed for resin slicing over to FDM. So some stuff they're pointing out is split cut merge, measurement, support painting they've got. Support's of course huge thing with resin prints. Yeah, banana for scale. Okay, I guess.
I need to check if PrusaSlicer in the model gallery, or how's it called? He also has a banana for scale. Anyways,
I don't think it does.
So, but the tools they're talking about are mainly for geometry manipulation, since the slicing approaches, or better said, the path generation, or that path generation is something essential for FDM printing. Before they also sliced the part and had to extract the perimeter and fill that with color basically, or just fill that layer with. They now had to develop a whole new set of algorithms to do all of the path planning for FDM printing, which.
Well, I mean, at its core, as far as I'm aware, the entire SlickTR toolpath really is just based on SVGs. It's a sequential process where it takes the STL, it slices it into layers, and you can even export SVGs on the command line from PrusaSlicer SlickTR. It then takes those SVGs and it infills it for each layer. But of course, it's not just per layer that you have to look at. You also have to look at like the previous layers. Like, is this a bridge? Is this an overhang? Yeah. Is this something that needs support material? And all that happens after the fact, sort of. But up until that point where you've got your layers sliced into SVGs, into vectors, it's the same thing, really. So kind of makes sense to just add that on top, just to say, hey, we're now going to create motion in that, and not just export it as a pixel image for the resin masking screens. Definitely.
I don't think that it is a real competition for other FDM slicers, but if you maybe started with resin printing and don't want to use two different tools, this might be an option, just to stay in that one tool and use it for your FDM printers and also for your resin printers. I wouldn't see me switching to Lychee Slicer at the moment. Only if there are certain features that are interesting, or of course model manipulation. If Lychee Slicers, I think I never used Lychee Slicer. If Lychee Slicer would be really good for model manipulation, things we talked about before, cutting parts, adding pegs and pins and things like that, not needing to switch back to another slice and just staying there is definitely a feature to look out for.
Yeah, anything that's competition, anything that's more options is good. But of course, I think we have to point out Lychee Slicer again. It is a paid product. There is a free version that you can do, that you can use, but there are now different subscription options, whether you want resin or filament or both. So I've just got the pricing page open here. The filament slicing, the Pro filament slicing package is $40 a year. The resin package is $60 a year, euros that is. And if you get both, it's $80 a year. So that unlocks the Pro, and then there's also a premium option for $40 a year. I don't know. Yeah, it is paid, but like I said, more options, even if it is a paid software, that's good. I think that the fact that there was Simplify3D, and the fact that there was that people saw, hey, there's features that could be implemented that people are willing to pay for, that are worth something to people. That did kind of incentivize, I think at the start, Ultimaker to really invest into Cura. And then later on, of course, also Prusa with PrusaSlicer, just to say, hey, this is something that people want and that is valuable to people. And if it's included with our machines, then that is extra value for our machines.
Yeah. So you also didn't try it?
Not the FDM version. I think I've had it open once or twice in the past, but I don't think I've ever printed anything yet.
Cool.
But it's there. Like it's an option if you want to try it out. There's a free tier. I don't know how the limitations are there, but more options. If you're not happy with what's included with your printer, give it a try.
Quick one. Upcoming festivals this year. It's gonna be more.
Oh yeah, there's now another one. So how many are we up to? 5? So there's NERF, the OG.
Midwest RepRap Festival, Goshen, Indiana.
Yes,
ERF.
That was the one that came after that. The East Coast RepRap Festival
near Washington, D.C.
Yeah. Philadelphia? No, that's where
between Philadelphia and Washington
Yeah, there. Then there's the Smurf. Now is it called Smurf? The Swedish 3D printer meetup.
Sweden 3D printing meetup.
3D PMS. So that. Then there's Smurf was the Sanjay Mortimer RepRap Festival.
Oh yes. That's gonna be in September.
That E3D is putting on with the Sanjay Mortimer Foundation in the UK. And there's now as well the Rocky Mountain RepRap Festival. And you also put the Bay Area Maker Faire in there.
That's another topic.
Not a specifically 3D printer festival. So I count 5, I think.
Yeah. Look at Rocky Mountain RepRap Festival gonna be at the end of April in Colorado, Denver, or is it Colorado? Colorado.
It's Colorado. And you
Denver,
going?
Colorado. I haven't booked my flights yet, but I will probably be there. I was a bit hesitant because it's the first year and I don't want to be the only one there and spending a ton of money on traveling and expenses. But it looks really well organized so far, and I talked to a couple of other people, and
if you compare it to NERF, like everything looks well organized.
Yeah. And in the end, the thing that I enjoy on those events is just seeing what people are doing and talking to the guys there. If there are enough exhibitors, it's got to be a fun time.
Even if there aren't, even if it's just a little group of people who all can nerd out about the same thing, I think it's going to be a fun time. That's been sort of the experience with the Sweden 3D printer meetup that I was at, I think twice. First, I was there at the very first time they put it on. It was a really nice small festival. And if the RMRRF
Festival.
the Rocky Mountains RepRap Festival is going to be in any of the spirit of all the other festivals, I think it's going to work at any scale. Probably if it gets too big, it's going to be less fun to attend. So
we'll see. I'm probably not going to go.
I feel like I just got to take it easy, and it's in 2 months already. I do want to go. I do want to, like, traveling is always heaps of fun, but I think I'm gonna have to skip this one. I'm gonna let you go, and you can report back maybe next year.
Yeah. So, yeah, my plan is to go. I actually wanted to book flights this week, and I'm really looking forward to, because just the area where it is I think way more impressive than Goshen. I don't want to rant about Goshen, but it's just everything is flat, and Denver is just it's beautiful. It's a beautiful area. So just want to be there for the looks.
Yeah, I've never been to that area of the US.
I've never been to Denver, but we traveled the West Coast. I think that was already over 10 years ago. I think that was in 2011. And we did all of, like, the national parks around that area, and it's just beautiful. It's just beautiful. And that's the reason why I want to go back, even though it's going to be a kind of work trip. But yeah. Yeah, but
you've learned from your previous trips, you're going to tack on a couple of days before or after, and just make it an extended work trip.
The current plan is to after RMRRF.
These names, man.
To fly to Los Angeles and visit Matter Hackers, and maybe I even have the time to go surfing with Dave there. I don't know.
That'll be sweet.
I plan to fly to Los Angeles, then on Monday, and probably on Thursday back home to Germany. Let's see if that's gonna work out. So
it's gonna be quite the trip, though.
It's gonna be quite the trip, though. I don't know, but the stressful it usually is, the much I usually enjoy it. So something new this year. And maybe just a last quick one. Have you ever been to the Bay Area Maker Faire?
I've been once. I think it was a couple years ago. 16, 17, 18. Yeah. Like one of the last ones that was put on before Make stopped existing, and now it's being put back on by whom?
By whom? By the by the science YouTuber guys. So William Osman, I think he's kind of the guy that tries to organize that for this year.
So I've been to Banff, and it's when I went, it was a massive event. So okay, I'm guessing it's not going to be the same scale then.
You can, well, there is the William Osman 2 channel where just a couple of days ago they released a video where they were in San Francisco checking out a couple of locations. I think that they want to make it happen. I don't know if they already realized what amount of organizational effort that this is going to be, but it looks as if another Bay Area Maker Faire, or I don't know if it's going to be like a real Maker Faire or at least a maker event, might be happening this year.
It would be really cool to see what they come up with. Whether it's because at a certain scale, you kind of have to go down that route where it's like, hey, everyone gets a little booth, and you get to present your stuff, and like 2/3 of the booth are selling you stuff. But I think when I was there, it was maybe a bit too big. I'm going to admit that it was a very commercial, very much into that, that spirit, and less of a maker fair. I've been to the smaller maker fairs in Munich, which I don't know if they're even still happening. But But that's literally just a little concert hall that they've got a couple people in there, and that feels much more like a maker fair and less of a maker sales pitch commercial bazaar. So yeah, interesting. So there's no concrete plans, dates, or anything yet.
I don't think so. I think they just mentioned that they gonna publish something soon.
So
as much as I heard, maybe summer this year.
I was gonna say, like, if they're in the planning stages right now, especially in San Francisco, I doubt it's gonna actually happen this year. That would be planned for next year then.
Yeah.
But yeah.
I think I can't talk about too much because I don't know how concrete those plans are. I just wanted to talk about like the official stuff that has already been communicated, and I'm looking forward to that because San Francisco is a really interesting or nice city, and so I think they want to set it up like as a mix of Maker Faire and VidCon, so that you also have your science YouTubers there and can on the one side make your meet and greets and on the other side show off your creations, which might be an interesting concept. But of course that leads to overcrowding probably, because you have many that are only want to attend this to meet guys like you and me, and not that many that are just interested in just amazing maker projects. But we'll see.
I'll keep a close eye on that, and see what actually comes out of it.
Maybe I can motivate you to join me there.
That would be pretty cool. Yeah, when I was there, I think after the show, I took a quick drive out to Printabot. To Brooke, and he's up to stuff as well. I think it was just a quick like 2.5 hour drive to his place. Yeah, but lots of stuff there. Obviously, it's everything. It's like Silicon Valley. I mean, what do you want?
All right. I think we won't be answering any questions today. We had a lot of like just catching up to do. If you guys have any questions, put them down in the comments. If you're listening, go to YouTube and put them there. I think that's the best way to get them to us. Or tweet at us.
That always works. At the Meltzone, we get those notifications too. And for the next one, we're gonna have a look through all the feedback channels.
Yes.
One last thing?
No last thing. I was just wondering if didn't you also use the multi Twitter account management tool, TweetDeck? But that's now part of Twitter, is it?
It's been part of Twitter for a while.
Okay.
So it's been. Yeah,
because I was wondering how easy checking different Twitter accounts with like external software is now, since have the APIs already been turned off? Or I don't know. That was something Twitter happening.
There's no like a free tier but I don't know. But yeah, TweetDeck has been part of Twitter for a while, and I think I even gave you access to the Meltzone account to that, didn't I?
Yes, you did.
Yeah,
you did.
But you never check in, which I don't blame you. There's enough stuff to keep track of.
I do now already have to manage my German YouTube channel.
Right. Yeah.
Topic for the next video. Topic for the next Meltzone episode.
Yeah, I've been dabbling in trying to translate some stuff as well, just to see how that all works out. But
we could hire an editor that does both of our stuff. Well, because see. It's a let's talk about that next time after the video. I mean, we could after recording.
My thought was like have a custom trained DaVinci 003 model that can translate the original scripts to German.
Yes.
Yeah.
Maybe.
Big topic. Okay.
Big topic.
But that's it for today. Thank you all for sticking around through almost 2 hours of Meltzone. I hope that made up for the lack of episodes over the last couple of months, but you know how it is, life, and we'll try to. We always say this. We'll try to keep a more regular schedule, but we probably won't. Thank you, Stefan, for your time. If you want to support us, that came off as like too quick. Thank you, Stefan, for your time. If you want to support us, you can do so on our patrons or through. Do we have YouTube memberships enabled on this channel?
Yes, we do.
We do. Yeah.
No, we don't. No, we don't. We only have super chats activated.
Okay, but we split the revenue evenly between our us two. So if you want to support us, that also helps, of course. We will see you on the next one.
Bye-bye.
Bye.